Hi everyone, this is the second part to the video comparing linear functions. I'm going to focus more on the word problems. So as a reminder, you're always trying to get to the equation y equals mx plus b. M is the slope, it's how much you're moving each time, how much you're changing. So you're using the rise over run formula on a graph or the slope formula. The b is the beginning or the starting point, and that's where you're starting at 0. 0 for the x variable. Usually that's like time, before time has even started. Okay, so we're going to do a couple of word problem examples. Here is the first one. It says that two sumo wrestlers decided to go on a special diet to gain weight rapidly, so very quickly. They each gained weight at a constant rate. So that's telling you that we're going to be using slope. The weight in kilograms of the first wrestler as a function of time in months is given by the following table of values. So the time in months, that's like your x, and the weight in kilograms is like your y. The graph of the weight in kilograms of the second wrestler as a function of time in months is shown below. So this is the first wrestler, and this down here is the second wrestler. Okay, so 1 and 2. Well, I can't even write anything over here. Okay. So the first question is, which wrestler weighed more at the beginning of the diet? So this right here is asking you the y-intercept for both of them. For the y-intercept on a table, you're going to have to figure out the pattern. So how much is it changing each time? Okay, so this is going up by 1.5. Between 4.5 and 6 is also 1.5. If you don't know it off the top of your head, you can take out a calculator. Like I'm going to need a calculator for this one. This is 101, 101 75th hundredths minus 95. So this is going up by 6.75. Then between these two numbers, 108.5 minus 101.75, that's also 6.75, which makes sense because it is going up constantly. Now, be careful, the slope here is not 6.75. It's the change in the y, which is 6.75, divided by the change in the x. Okay, I know it's not asking me for slope, but just gonna figure that out now. So it's changing by 4.5. 4.5 kilograms per month. Okay, that's the slope. Now again, it's asking us for the beginning of the diet. So beginning of the diet means the time is at 0. So before the two sumo wrestlers even started comparing with each other, what was this person's weight? So what I can do is I can go backwards. I would subtract 1.5 from 3 because that's the pattern. So I would get 1.5 again. And then look at that, I'm going to subtract 1.5 again to get to 0. So that's perfect. Here I would do the same thing. I jumped twice, so here I'm also going to jump twice. I'm going to subtract 6.75 from 95 because that's how much it's changing each time. So I get 88.25. I'm going to change one more time according to that rate of change. So that's 88.25 minus 6.75, and that's, get a different color so you can see that, 81.5. So at time 0, at 0 months, before they even started comparing their weights on this special diet, the first wrestler was at 81.5 kilograms. Okay, so we have to compare, so I need to do the same thing with the second wrestler. The second wrestler, you can very easily figure out the weight that the second wrestler started off with. It's where the graph starts. That's the y-intercept. It's where it touches the y-axis. So the second wrestler started at 75 kilograms. So we're looking at 81.5 versus 75. So is it the first or the second one that weighed more? It would be the first one, the first wrestler. Okay? And then remember, this slope is 4.5 kilograms per month, because the next question is asking us which wrestler gained weight faster. This one gained 4.5 kilograms per month, and the second one, we're going to have to figure out its slope to figure out how much this wrestler is gaining weight, going up. I'm going to use a different pen since I cannot draw there. Okay, so for this one, to find slope, I can use rise over run. Oops. So here's the first point, and here's the second pretty point. So in order to go from this point to the other point, making my triangle, I'm going to go up 1. So that one jump is from 75 to 80. So it's really going up 5. From 75 to 80, I'm going up 5. And then now I'm going to jump over twice. Jumping over twice is just getting to 1. I don't know why it's doing this, but it's just going over 1. Oh man. So it is a rise, that's strange, a rise of 5, rise over run, and a run of 1. So that's 5. So this wrestler, sumo wrestler, is gaining 5 kilograms per month because it went up 5 over 1. So you just have to watch your scales. One jump here is 5 kilograms, while 2 jumps here is 1. So just be aware you're not putting like 1 over 2 for a half. So who is gaining more weight? We're comparing 5 and 4.5. So let me get out of here first. There we go. So 4.5 compared to 5. So it looks like the second sumo wrestler is gaining weight faster. Okay, that's one example. Okay, for this problem, they're saying Ortby wants to buy towels online. There are 2 stores with the kind of towels that she wants. The first store charges $20 per towel, and the delivery charge is $25. The following equation gives the total price in dollars of an order from the second store, including delivery, as a function of the number of towels. P equals 35 plus 18n. Which store charges more per towel? All right, so looks like the first store, they don't give you an equation. So we can create an equation. P is the price, so that's like your y equals. Okay, so your total price at the end is going to equal to something plus something times n, just like the second one. So it's kind of like your y equals mx plus your b. Okay, so here they have a charge of $20 per towel. Per tells you that every time you get an additional towel, it's going to change. It's going to be an additional $20. And then the delivery charge is $25. So think to yourself which one is going to change and which one's not going to change. The delivery charge is not going to change. It's just going to be added to your bill at the end. You could buy something that's $1, but you're still going to have to pay that $25 delivery charge. Or you can buy something that's like $800. You're still just going to pay $25 for your delivery. So the 25 is not going to change. It's just going to be added to your answer. And then the 20 is going to be multiplied by n, the number of towels that you buy. So each time you get an additional towel, it's going to be multiplied by 20. So it's going to increase. Okay, same thing here. They gave you the equation, so you have to make sense of it. The 35 is not being multiplied by anything, so that's your delivery charge. And then the 18 is being multiplied by n, so that's your towel price. Just like this one. Okay, this one is your towel price. And this one is your delivery charge. Okay, so everybody starts off with a $25 delivery charge. So as always, this is your start, your y-intercept. And then this is how much it's changing each time you get new towels. Okay? So now let's read the question. Which store charges more per towel? Let's see. This is the charge per towel. Let me put delivery here. Charge per towel is 18 for the second place, and the charge per towel is 20 for the first place. So who charges more? That would be the first store, because they only charge $20 per towel. Okay. The second store has the higher delivery charge though. So it's kind of like when you buy something on Amazon, like, oh, it's really cheap, but then it's like, oh, well, they're charging me more for delivery. So they kind of even each other out. It just depends on how much you're buying, right? Let's see. The second question says Orpi needs 15 towels. Which store is cheaper for her, right? So if she's getting something like 15 towels, we had to figure out which one is better, because it could be the one with the cheaper delivery charge, or it could be the one with the cheaper towels. So 15. The good thing about equations is you can just put in 15 instead of that n. So for the first equation, P equals 25 plus 20 times the number of towels, we know it's 15. So then all I have to do is just solve this problem. Let's see, 15 times 20, I'm going to need to solve first, and that's 300. So at the end, for 15 towels, she's going to spend $325 at the first store. At the second store, the total price is equal to 35 plus 18 times the number of towels, 15 towels. And let's see, we need to solve 18 times 15. So that's 270. 270 added to our delivery charge is $305. So which one is cheaper for 15 towels? That would be the second one. You would think that it wouldn't be the one with the larger or more expensive delivery charge, but it is. Okay? So again, for these problems, you should just pay attention to the slope and the y-intercept. Slope is always going to be the amount changing, rise over run on a graph, and then y-intercept is the starting place. So even though in this question it doesn't say start, the delivery charge is technically where you start at, because that's the amount you're gonna have to pay before you do anything else. That's already in your shopping cart as a fee. Normally we don't see it calculated till the end, but it's like still there, right? It's just kind of an illusion if you have $0 charged in your shopping cart. You don't add it till the very end, but it's technically there the whole time. So that one's kind of tricky. Okay, and then if the question asks for a specific amount that someone's buying or making or whatever, then you just have to put it into the equation and solve it. Multiply first, then add. Okay, let me know if you have questions as you work on these, and I'll see you in class.